Okay, so here is the first practice quiz that I gave you. I've filled in some of the definitions that we'll need for this. You don't need to write out these definitions, but you need to have them locked into your brain. So the first thing you have to do is take a deep breath and look at the function. So this is about as bad as it gets. They're very weird, domain and codomain. So here the domain is the natural numbers cross the positive integers, not strictly positive, it includes 0. So this is the integers greater than or equal to 0. So that means I'm taking ordered pairs. You see H consumes an ordered pair, and it spits out an integer. How does it do so? It takes the number minus 1 to the power of the first coordinate, and then it multiplies it times the second coordinate. So I'm getting plus or minus 1 times whatever positive or 0 integer. So the first thing to do is just to get you to calm down and ask you to compute what it is in one case. So this says take minus 1, raise it to the a power, and multiply it times the second coordinate, which is 0. So in this case, a is not a is 1, right? So I get minus 1 times 0, which is 0. Now the other thing that you're supposed to notice here is this tells me something. I notice that no matter what I have in the first coordinate, if my second coordinate is 0, I'm going to get 0. And that gives me an idea of how I can show that it's not injective. Because remember, when it's not injective, I want to show that there's two inputs coming from this n cross greater than or equal to 0 integers. So we've got an a and a b in here, and an a prime and a b prime that's in there that are not equal, but that h maps to the same place. Okay, so you might want to pause the video and just try and do that based on this example right here. I'm going to assume that you paused the video, and we're just going to go ahead. So I'm going to notice that h of 1, 0 we showed was equal to 0 above. Similarly, h of 2, 0 is minus 1 squared times 0, which is equal to 1 times 0, which equals 0. So now h of 1, 0 equals h of 2, 0, but 1, 0 is not equal to 2, 0, so h is not injective. Okay? You need all the stuff in blue. You can't get away with less than that, but you don't need the pink. Okay, so our next job is to show that this map is surjective, and this one, I will freely admit, is a pretty tough example, because your first guess is to say, oh, well, this maybe isn't even a big deal, right? In order to get an integer here, why don't I just ignore this part, make this an even, right? If I take minus 1 to an even power times the integer that I'm trying to hit, and I'll get it. Okay, so you might want to pause the video and work out that argument, which is running through the fact we want to show for any integer there exists an ordered pair, so a natural number, comma, a positive integer, so that when I take h of a, b, I get c. All right, and then you can come back. I'm going to assume that you've come back from doing that, and I will point out that that argument only works when we have a positive or 0 integer. And the reason is because that's all that my domain has. So we're going to do this by cases. Case 1 is going to be when I have c contained in the integers such that c itself is greater than or equal to 0. Okay? In that case, I'm going to show that it's surjective. I'm going to come up with an a comma b that maps onto it. Well, I'm going to notice that in this case, I can consider 2, c, because that is 2 is a natural number, and c is a number greater than or equal to 0. So 2, c is in my domain. That tells me that h of 2, c is equal to minus 1 squared times c, which is 1 times c, which is c. And that tells me that c is contained in the image of h. And so that tells me everything that is greater than or equal to 0 is contained in the image of h. But again, that's not enough, because the codomain isn't just the positive integers. it's all integers. What if c starts out as -5? So this wouldn't be part of your proof, but I'm just going to put it in as a little example. So caution, if c equals, say, -5, then h of 2 comma -5 is undefined, because 2 comma -5 is not an element of the natural numbers cross the positive integers. All right, so we can't use that argument, so we need another argument for the negatives. So case 2 is when c is an integer such that c is negative. Well, in that case, so notice, since c is less than 0, that tells me that negative c is greater than 0, which tells me that negative c is in the set greater than or equal to 0. It's also in the set strictly greater than 0, but that's not what I care about. So consider now, if I just take h of 2 comma negative c, that would be -1 times c, -1 times 2 to the squared times negative c, which would be 1 times negative c, which would be negative c. But that's not what I wanted, right? I didn't want to get to negative c, I want to get to c. Negative c is positive, c is negative. Okay, so how can I correct what I did? Maybe instead of taking a 2 here, I should take an odd number. Then I would have a negative here times the negative c would give me exactly the c that I wanted here. Okay, you see what the problem is. Our goal, remember our goal is for every integer, we find an a and a b so that h of ab is equal to exactly that c. That worked out fine here when c was already positive, but down here when c is negative, in order to find some value that I can put in the second coordinate, it has to be positive or 0, so I put negative c here, but then I want the output to be my original number c, not -1 times it. So I just correct this. So instead of taking 2 here, what should I take? I'm going to instead take h of, I could do 1. Negative c is -1 to the 1 times negative c, which is -1 times negative c, which is c. Okay, so I don't need to erase all of this. I'm just going to put a line through it because that was a failed attempt. Okay, and so now what I get is I can see that c is contained in the image of h. And so what have I shown? I've shown that every integer which is negative is contained in the image of h. So I've shown that these integers are contained in the image of h. So now I've got the positive integers are in h and the negative integers are in h. So combining these two gives me, so from case 1 and case 2, case 1 plus case 2 imply that the integers are contained in the image of h, and of course the image of h is contained in the integers because that was the codomain, so that tells me that the integers are equal to the image of h, and that tells me that h is surjective. All right, and so now what you might want to do is try the other quiz, which was this one right here, and give it a shot and see how it goes. Okay, enjoy.